Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to The Explainer. I'm so thrilled you're here today because we're going to unpack something that literally keeps our modern digital world spinning. We're diving into a structured breakdown of exactly how we make sure the software we rely on actually works the way it's supposed to. So if you've ever wondered what stands between a perfectly functioning app and, well, absolute digital chaos, you are in the right place. Let's just jump right in. Let's start by confronting a universal enemy. I mean, we've all been there, right? A sudden crash, a deep-rooted code bug, or some random system glitch right in the middle of whatever you're trying to do. And look, these aren't just minor annoyances. They literally cost businesses millions of dollars and can instantly destroy user trust. So, how do development teams actually fight back against this and secure the pipeline? Well, enter software testing. This is a critical phase of the software development lifecycle, and its entire job is to step in before the software ever reaches your hands. Think of it like a giant safety net. It identifies defects to ensure an application doesn't just work correctly under the hood, but actually meets the user's requirements. It's really the ultimate quality control mechanism designed to save us from those everyday digital headaches and massively improve the overall quality, reliability, and performance of the systems we build. So here's our roadmap for today. We'll kick things off with why testing fundamentally matters. Then we'll explore 3 specific methodologies: the white box, the black box, and the gray box, before finally bringing it all together to compare the 3. All right, section 1, why software testing matters, finding the flaws. You know, what's really fascinating here is the sheer scope of what testing actually covers. Most people just assume testing is, hunting down bad code. And yeah, sure, it absolutely identifies hidden bugs in the code. But look at that second point. It uncovers missing user requirements. This is absolutely massive. You could write a piece of code flawlessly with 0 technical errors, but if it doesn't do what the user actually needs it to do, it's still a total failure. Testing squashes those glitches across mobile and web apps, making sure the final product delivers top-notch quality, rock-solid reliability, and peak performance. It's really not just about making the code right, it's about making the right product.
Moving on to section 2. White box testing, the developer's view. For this next part, I want you to go ahead and put on your developer's hard hat. So, white box testing is all about examining a product's underlying structure and architecture. The absolute key phrase you need to remember here is full knowledge. Full knowledge of the internal code and logic. Imagine having the complete architectural blueprints of a house before you go in to inspect it, right? You know exactly where the plumbing runs, where every single electrical wire is, how the foundation is laid out. That is exactly what white box testing is for software. The tester sees absolutely everything.
And because of that complete transparency, it actually goes by a few other names that perfectly describe it. You'll often hear it called glass box testing, clear box testing, or structural testing. Just picture a literal box made of clear glass. It is a highly code-driven approach where the tester will intentionally design test cases to run through multiple specific paths within the software's logic. Having this level of deep internal access means developers can meticulously enhance the design, lock down security, and validate how things flow from the inside out. Typically, you're going to see this applied right at the foundational levels of development, specifically for things like unit and integration testing. Now, this brings us to a really brilliant dividing line in the world of software testing. We just looked at the white box approach, which, as we established, is intensely code-driven with 100% visibility. But now, we're going to do a sharp pivot. We are moving away from complete transparency to total opacity, from full visibility to literally 0 visibility. Let's talk about black box testing. All right, section 3, black box, the user perspective, or dealing with unknown internals. Go ahead and step right into the shoes of the everyday end user. So let's define this black box. The term literally refers to a system where the internal mechanics are completely unknown to you. In this method, the tester has absolutely no idea what the internal code looks like. Instead, the testing is purely against the system's inputs and outputs. Basically, you put something in, and you check to see if the right thing comes out, without ever peeking at the machinery doing the actual work behind the scenes. Let's break down how this actually works in practice. Because it's an input-output driven approach, it's done entirely from the user's perspective. Think about it. When you use an app on your phone, you don't know the code, do you? You just know that when you tap submit, you expect a confirmation message to pop up. That is black box testing in a nutshell. And because it focuses so heavily on whether the app actually functions as requested, it's also known as functional testing. What's really fascinating here is just how versatile this is. I mean, it can be applied at every single level: unit, integration, acceptance, and even security testing. But its primary unbeatable advantage? It ruthlessly prioritizes the actual user experience, functionality, and usability over whatever is going on in the underlying code.
Okay, moving on to Section 4, Gray Box Testing, the hybrid approach.
So, what do you think happens when you combine the best of both of those worlds? Well, you get gray box testing. This is a hybrid method, and the absolute defining characteristic here is that testers have partial knowledge. They understand the internal data structures and the architecture, so, they kind of know the lay of the land, but they completely lack access to the granular source code. It's this brilliant middle ground that bridges the gap between the deeply technical developer and the strictly functional end user. Because it sits squarely in the middle, gray box testing is sometimes called translucent box testing. And I think that's a great metaphor, honestly. You can't see the exact crystal clear details of the code like you would in a glass box, but you can definitely make out the overarching shapes and structures through the frosted glass. To pull off this combination of black box and white box techniques, testers rely a lot on high-level documents, things like database schemas and architecture diagrams. So they aren't reading every line of code, but they fundamentally understand the data flow. And this makes it incredibly powerful for sniffing out hidden defects, security vulnerabilities, or deep architectural issues. Naturally, it's become super common in API testing, database testing, and validating fully integrated systems. All right, Section 5, comparing the three boxes, the ultimate lineup.
Let's just walk through this master comparison together, because it really ties everything up. Take a look at the knowledge of code here. It scales perfectly, right? From none in the black box all the way to full in the white box, and then settling comfortably at partial in the gray box. And because of that, the testing approach completely shifts. It goes from strictly input-output to intensely code-driven to a really smart combination of both. Notice the perspective shift, too. We move from the end user straight to the developer and then land on a mixed perspective. I also really love looking at the efficiency breakdown. Black box testing is incredibly quick because, frankly, you don't need to know or read any code to pull it off. White box testing is incredibly thorough, but obviously it takes way more time and deep coding knowledge. And the gray box? It offers a highly effective, balanced approach. By using all three of these methods where they make the most sense, from acceptance testing all the way down to unit and API testing, developers can make sure literally no stone is left unturned.
While we have definitely covered a lot of ground today, but as we wrap up this explainer, I want to leave you with a final kind of provocative thought to ponder. If white box testing gives us absolute full visibility into the underlying code, giving us the power to see every single logic path, why do we still absolutely need the black box approach to find some of the most critical project-breaking bugs? Think about that for a second. Think about the fundamental tension between knowing how code works theoretically in a vacuum versus how real, actual humans experience it out in the wild. Thanks so much for joining me on the Explainer today, and keep questioning the systems around you.